Look at this. Giant pumpkins. Growing in the middle of the Sahara Desert. This is real. But how? This land has been completely dead for centuries. No rain. No shade. No life. So how are these massive pumpkins here? Let's go back to the beginning. This is the Sahara Desert. The largest hot desert on Earth. 9 million square kilometers of almost nothing. No rivers. No forests. No farms. Just sand, rock, and endless silence. The temperature here regularly reaches 52 degrees Celsius. The ground itself becomes too hot to touch with bare hands. At night it drops to near freezing. Nothing survives easily here. This specific stretch of flat cracked orange earth in southern Algeria has not produced a single living crop in recorded human history. The soil is almost pure sand. It holds no nutrients. It holds no water. Rain comes perhaps 3 times a year. And when it does, it disappears into the sand within minutes. Like the earth is swallowing it whole. Farmers from the nearest village tried growing here generations ago. Their great-grandfathers tried. Their grandfathers tried. Their fathers tried. Each time the result was the same. The plants would sprout. Struggle for a week. Then curl up and die in the brutal heat. The village had accepted it. This land was dead. It would always be dead. But then a man named Karim came back to his village. After 8 years studying agricultural engineering in the city, he stood at the edge of this dead flat orange desert. And he didn't see what everyone else saw. He didn't see failure. He didn't see a curse. He saw a laboratory. A place where no one had yet found the right formula. He was going to find it. Karim had studied desert agriculture for 8 years. But book knowledge alone wasn't enough. He needed a system. A complete system tailored specifically to the brutal conditions of the Sahara. His plan had 4 parts. Part 1. Soil transformation. He had identified a specific biochar compound, made by burning organic agricultural waste at very high temperatures in a low-oxygen environment. The resulting material is a fine black carbon-rich powder, almost identical in appearance to charcoal dust. Biochar has an extraordinary property. It acts like a sponge inside sandy soil, holding water and nutrients in place instead of letting them drain away. Karim mixed his biochar with camel manure compost and a specific desert mineral clay. He called this mixture Desert Black. Part 2. Deep trench beds. Not shallow rows. Deep rectangular beds dug 40 centimeters into the Saharan sand, wide enough for 2 pumpkin plants per bed. Each bed lined at the bottom with a thin layer of crushed limestone gravel for drainage control, then filled completely with the Desert Black mixture. Part 3. Shade netting. Thin white agricultural shade netting stretched on bamboo poles 2 meters above each bed, filtering 30% of the brutal direct sunlight, reducing the surface temperature inside each bed by up to 12 degrees. Part 4. Buried clay pot irrigation. Ancient technology. Used in Iran and North Africa for thousands of years. Called olya irrigation. Large unglazed clay pots buried completely in the soil beside each pumpkin plant. Filled with water every 3 days. Water seeps slowly through the porous clay walls directly into the root zone. Drop by drop. Continuously. No evaporation. No waste. Karim worked for 17 days to prepare his beds. His father, who had stopped farming decades ago, came out every morning and watched in silence. On the 17th day, Karim's father picked up a shovel and started digging alongside his son. Without a word, Karim had chosen 3 pumpkin varieties, all giant cultivars. The first, Atlantic Giant, the variety used in world record pumpkin competitions, known to produce fruits weighing over 400 kilograms under ideal conditions. The second, Dill's Atlantic Giant Improved, a specifically bred version with reinforced vine structure for harsh growing conditions. The third, Rouge Vif Diatamps, a French heirloom variety, deep red-orange, flattened disc shape, extraordinarily sweet flesh. Each variety was planted in its own separate row of deep desert beds. Karim planted the seeds himself. Not saplings. Seeds. He pushed each large flat pale seed 2 centimeters deep into the warm dark desert black soil. Then filled each buried clay pot with exactly 4 liters of water. The water began seeping immediately through the porous clay walls, moving silently through the dark soil, toward where the seeds lay. Then Karim did something unusual. He pressed his palm flat against the dark soil surface above each planted seed, and held it there for a moment. His father asked him what he was doing. Karim smiled, and said he was introducing himself to the seeds, telling them where they were, telling them what was expected of them. His father shook his head slowly, but then quietly he knelt down, and pressed his own old palm against the dark soil. On the 7th day after planting, the first green shoot pushed through the black desert black soil, a tiny curled pale green hook, straightening itself upright in the desert air. Karim photographed it immediately. He sent the photo to his university professor in the city. The professor replied with a single sentence: "This is either the beginning of something extraordinary, or the last thing that plant will ever do." What happened next surprised everyone, including Karim. Pumpkins are known as fast growers, but what these seeds did in the Saharan desert conditions was beyond fast. It was explosive. Within 4 days of that first shoot appearing, all 32 planted seeds had broken through the dark soil. Every single one. A 100% germination rate. In the Sahara Desert. By day 10, the seedlings were already 30 centimeters tall, with large healthy dark green leaves. By day 18, the first long thick vines began extending outward from the base of each plant. Thick as a finger. Bright vivid green. They moved across the dark soil and out onto the surrounding orange desert sand, sometimes growing 20 to 30 centimeters in a single day. The villagers came to watch. They had never seen anything grow like this in their desert. One elderly woman said the vines looked like they were trying to escape. But they weren't escaping. They were claiming territory. By day 25, the vines had spread so far that each plant's vine network covered an area larger than a dining table. Large broad pumpkin leaves, some the size of a child's outstretched arms, covered the desert floor. They were creating shade, their own microclimate. Under those massive leaves, the soil temperature dropped by 10 degrees. The buried clay pots kept moisture consistently available. The biochar in the desert black mixture was holding every drop. Not one drop of irrigation water had been lost to evaporation. The system was working perfectly. And then on day 29, the first flower opened. A blazing golden yellow trumpet-shaped flower, the size of a human hand, opening wide in the Saharan morning sun. The golden flowers lasted 3 days. Then the magic truly began. At the base of each pollinated female flower, a tiny green swelling appeared. Round, firm, no bigger than a marble at first, but growing, always growing. The desert bees found the pumpkin flowers within 24 hours of opening, far faster than anyone expected in such an isolated desert location. A desert ecologist from a nearby research station later explained why. Golden yellow is the most visible color to bees at long distance. And these flowers were enormous. And there were dozens of them, blooming in a landscape that had been flowerless for generations. The bees had detected them from over 8 kilometers away. Karim watched the first tiny pumpkin fruit form. On day 31, he measured it every single morning. Day 31, 2 centimeters diameter. Day 35, 6 centimeters. Day 40, 15 centimeters. Day 45, 28 centimeters. Day 50, 42 centimeters. The growth rate was staggering. Karim sent weekly fruit measurement data to his professor. After week 6, the professor stopped replying with analysis. He just replied with one word each time. Impossible. 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 By day 60, the largest pumpkin in Karim's plantation had developed into a massive rounded form. Its skin was changing color. From deep green to pale green. From pale green to cream. From cream to the first hints of deep burnt orange. The pumpkin was approaching maturity. And it was enormous. On the 78th day after planting, Karim walked slowly along the rows of his plantation. He stopped at the largest pumpkin. He placed both hands on its warm skin. It was hot from the desert sun, but firm, dense, solid. He knocked his knuckle against the surface. A deep, hollow, resonant thud. The sound of a perfectly ripe pumpkin. He took out his measuring tape one last time. 112 centimeters in circumference. He weighed it using a hanging agricultural scale. 68 kilograms. He stared at the number. 68 kilograms. Grown in the Sahara Desert. From a single seed. In 78 days. Word had spread through the village the night before. By sunrise, over 50 people had gathered. Farmers, scientists, village elders, children, a journalist from a regional newspaper, a camera crew from a local television station. Karim stood beside the enormous bright orange pumpkin sitting on the cracked orange Saharan desert sand. He said simply, "This is what the desert gave us. We gave it the right conditions. It did the rest." Then came the cutting. Karim's father insisted on doing it himself. The old man who had given up on this land decades ago. He took a large sharp knife and drew it carefully through the enormous pumpkin. The knife moved through the dense orange flesh slowly. Juice ran down the sides. Deep orange. Vivid. Almost luminous. The two halves came apart. The inside was extraordinary. Dense deep orange flesh. Thick. Smooth. Intensely colored. Glistening with natural sugars. The cavity at the center was packed with large flat pale seeds. The smell hit everyone immediately. Rich. Sweet. Warm. Like caramelized pumpkin and honey and something else entirely. Something no one could name. A scientist from the regional agriculture department was there. He had brought a portable Brix refractometer. He took a small juice sample from the cut pumpkin surface. The reading came back. 16.8 degrees Brix. He checked it twice. He showed it to Karim without speaking. 16.8. A premium culinary pumpkin typically measures between 8 and 12. This desert pumpkin was almost double the standard sweetness. The scientist looked at the orange desert around him, then looked at the pumpkin, then back at the desert, and quietly said, "I don't understand this place." The scientific team arrived 2 days after the harvest. 6 researchers from 3 different universities. They spent 10 days at the site, taking samples, running tests, measuring everything. Their findings explained most of what had happened, but not all of it. Here is what the science showed. The biochar in the desert black mixture had performed exactly as Karim predicted. It had increased the soil's water retention capacity by over 300%. In pure Saharan sand, water disappears within minutes. In the desert black mixture with biochar, water remained available in the root zone for up to 4 days. The buried clay pot Olya irrigation delivered water continuously. No surface evaporation. Zero waste. The pumpkin roots had complete and constant access to moisture. Something they would never have in natural Saharan soil conditions. The shade netting had reduced the direct sunlight load on the plants by 30%, while still allowing 70% of the light needed for photosynthesis. It was the precise balance, intense light without lethal heat stress. A balance almost impossible to achieve in the desert. Until now. But here is the part that puzzled the scientists most. The sugar concentration. 16.8 Brix. Nearly double the standard level. The scientists had a theory. Desert stress response. Even with the irrigation and shade netting managing the worst of the conditions. The pumpkin plants were still experiencing a degree of environmental stress. Higher than in a temperate farm. And plants under controlled stress do something extraordinary. They produce more sugar. More sugar in the flesh. More sugar means more flavor. More flavor means a more valuable crop. The desert hadn't just grown pumpkins. It had made them better. Within 1 week of the harvest, Karim posted a single video online. 7 minutes long. Showing the preparation, the growth, and the cutting. In 48 hours, it had been viewed 11 million times. In 72 hours, 26 million. Comments poured in from every country on Earth. Agricultural companies reached out with partnership offers. 3 universities invited Karim to present his research. The regional government sent a team to assess the potential for scaling the project. But more importantly, 5 farmers from Karim's own village came to him the week after the harvest. They wanted to learn. Karim spent 3 weeks teaching them everything. The biochar composition, the desert-black mixture ratio, the Alya pot burial depth, the shade netting angle, the exact seed varieties, the watering schedule. He gave them seeds from his own harvest. He gave them his research notes. He gave them his time. By the following planting season, there were 12 new pumpkin plantations in the region. Then 27. Then 41. The Algerian Ministry of Agriculture launched a formal desert agriculture initiative. Based directly on Karim's method, training workshops were established in 3 provinces, and the giant bright orange pumpkins of the Sahara began appearing in markets across North Africa. Labeled simply, Sahara grown. And every person who bought one and cut it open at home had the same reaction, the same look of disbelief, the same deep rich desert sweetness. The desert had given something extraordinary to the world, because one young man had asked it the right questions. So let's ask the real question. What does this story actually mean? Is it about pumpkins? No. Is it about the Sahara Desert? Not entirely. It is about something far more fundamental. It is about what happens when someone refuses to accept the verdict of the past. Every generation before Karim looked at this land and saw the same thing. Failure. Impossibility. Death. They weren't wrong about what they saw. The land genuinely was hostile. Genuinely was dry. Genuinely was brutal. But they asked the wrong question. They asked, can anything grow here? And the answer was always no. Karim asked a different question. He asked, what would this land need to become generous? And the desert answered, it needed the right soil chemistry, the right water delivery, the right amount of shade, the right seed. It needed someone to stop fighting its nature and start working with it. That shift, from fighting a problem to understanding it, is the difference between 1,000 years of failure and a single season of abundance. The same principle applies everywhere. To businesses that seem impossible to build, to relationships that seem impossible to repair, to versions of yourself that seem impossible to become. Stop asking if it can work. Start asking what it needs to work. Because Karim's desert had not changed. The sand was the same sand. The sun was the same sun. The heat was the same heat. Only the approach changed. And everything else followed. Every morning now, Karim still walks out to his plantation before sunrise. He checks the clay pots. He checks the soil moisture. He checks the vines. He has not changed his routine since day one. His father walks with him now. Every morning. Side by side. 2 men who both believed in the same piece of impossible land. One when it was easy. One before it was. If this story moved something in you, share it with someone who is standing at the edge of their own desert right now, looking at dead land, seeing only failure, and needing someone to remind them that the desert is not your enemy. It is just waiting for you to ask it the right question.